Right, so the next topic within this unit is polynomials. Okay, this is a very important topic, and it's one that's used across a number of different topics across the 3 units, or across the remaining 2 at least. Right, I know you're probably thinking, what the hell's a polynomial? But you've actually already covered a lot in terms of polynomials. But it's just a kind of an overarching bracket of a number of different types of basically expressions. Okay, so I'm going to list these expressions, but the idea is that they are all polynomials. But the general definition of a polynomial is simply the sum or difference of algebraic terms that have whole number indices. So 3x squared minus 5, we've already seen it's a quadratic, but that's a type of polynomial. X cubed minus 2x squared plus 7 is a cubic, and that's a polynomial. Okay, we've already kind of covered that a lot in differentiation. X to the power 4 minus 7x cubed plus 3x squared minus x is a quartic. Okay, and then we've got the basic one, which is just a linear equation. But they are all polynomials because they have multiple different algebraic terms within them, and obviously different indices as well. Okay, so these are all polynomials, and this is kind of the topic that we're moving on to. And it's dealing with these. Obviously, 2 of them we've already dealt with quite a lot in terms of linear equations and quadratics. So we're mainly going to be looking at cubics and quartics, and what they mean in terms of both graphs, in terms of the equations as well. Okay. So it helps to know a couple of different terms, a bit about the language that we use around polynomials. So when we're talking about a coefficient, it's the number, or maybe even a letter multiplying a variable. So for example, if you had 3x squared, the 3 is the coefficient. Okay. When we're talking about the degree of a polynomial, it's the value of the highest power. So you might have different powers within the kind of expression, but when we're talking about degree, it's the highest power within that. Okay. So for example, if you had x cubed minus 5x to the power 4 plus 1, the degree is 4. So it's not just the first one. Okay, you got to look at the kind of the whole thing, because generally we order them in a kind of in order. So if you see these ones above, they're all pretty much in order from highest to lowest power. But when we're talking about degree, it's the highest power within that expression. And obviously, when we're dealing with negatives, we don't necessarily want to put the negatives at the start. Just keep an eye out for that. If we're talking about a constant, it's a number without a letter. So for example, x to the power 4 minus 7x squared plus 3x squared minus 1. The minus 1 at the end is the constant because it doesn't have an x. In a way it does, it's got x to the power of 0, which is obviously 1. But nonetheless, when we're writing it like this, there is no letter there, in which case the constant is the bit at the end. Okay, so just a little bit in terms of the language that we're going to be using, you're going to be seeing, you're going to be hearing of quite a lot. Right, one of the main things that we want to do with polynomials is factorize them. Okay, so when we factorize them, we can find the roots. So obviously this is going to help us when we actually want to draw the graph. We can find the point where it crosses the x-axis. But we're going to be looking at this in terms of when perhaps 2 lines meet, and we obviously want to find the kind of the points where they meet. That's what we mean by the roots. So in other words, the points at which the expression equals 0. Okay, so we've done this also obviously with quadratics, but I'm just going to do this example. So you've seen this already. You don't need to copy this down if you're copying up notes. But this is more just to get us used to the language and the different things that we see happening around this kind of situation. Okay, so we've got f of x equals x squared minus 4x plus 3. We want to know where the curve cuts the y-axis. Okay, so we already know that when something cuts the x-axis, that y will equal 0, in which case we set the equation equal to 0. So x squared minus 4x plus 3 equals 0. And then what we want to do with this is we want to factorize it. Okay, so we split it into the 2 brackets, x minus 1 and x minus 3. And then we've got our 2 solutions there. X minus 1 either equals 0 or x minus 3 equals 0, in which case x equals 1 and x equals 3. Okay, we'll answer the question, curve crosses the x-axis when x equals 1 and x equals 3. But in terms of the notation here, in terms of how we write it with function notation, what I want you to think about is the fact that f of 1, so in other words, when we put 1 back into this equation, what we find is that the equation will equal 0. So 1 squared is 1, minus 4 times 1 is minus 4, and we add on the 3, we get 0. Likewise with the 3. 3 times 3, 3 squared is 9. Take away 4 times 3, which is 12. That gives us minus 3 plus 3 is 0. So it's important to realize this. So when you put 1 into that equation and when you put 3 into that equation, you get 0. So this is going to be really useful for when we're dealing with much more complicated equations, in other words, cubics and quartics. Okay, so we're going to use that in reverse in a second, but it's important to realize that 1 and 3 are factors of x squared minus 4x plus 3. X minus 1 and x minus 3 are factors 2. Okay, so we'll extend this onto factorizing and thus finding roots of polynomials that have a degree greater than 2. So we've not really factorized this kind of thing yet. So anything that's got x cubed, unless we can take out a common factor, we've not actually factorized it, but we're going to do it in much the same way. And it's important to know these different things to kind of start us off in our factorizing. Okay, Right, as a general rule, if f of a equals 0, then x minus a is a factor of f of x. So you just saw that, okay, f of 3 was equal to 0 in that previous one, and x minus 3 was a factor of the original function, okay? And we can say the converse is also true. If x minus a is a factor of f of x, then f of a equals 0. So it's not going to make a massive amount of sense just yet, that, okay? But when we get a few examples, it's important to use this language and understand this language, okay? So for example, is x minus 1 a factor of f of x equal to x cubed minus 3x squared plus 3x minus 1? Right, this is going to be a common question, a version of this at least, okay? So get used to this. But the idea is we don't want to use that necessarily in that form, but because if x minus 1 is going to be a factor, then 1 would be a factor of the whole thing as well. So what we can do is we can put 1 into the equation, and if we get an answer of 0, which we do in this case, then we know it must be a factor. And as I say, using that kind of those two different methods will help us when we're looking for all of the factors of this. Okay, so 1 into the equation basically comes out as 0, and what that tells us that since f of 1 equals 0, x minus 1 is a factor of f of x. Okay, right, you've seen already with a couple of topics that we've done, they care quite a lot. Language is quite important in terms of how we write our answers. So this sentence here, you're going to see quite a lot. You're going to have to write quite a lot as well. So since f of 1 equals 0, x minus 1 is a factor of f of x. Okay, so we've answered the question. Right, if we weren't asked to merely prove a factor, but actually find one from scratch, there are several different methods which you can use, okay? Right, we're going to use a method called synthetic division, which comes from looking at nested form, right? You're going to hear these terms, I won't worry too much about them, but the method of synthetic division is important, and you're going to use a hell of a lot of from now on. I'm going to show you where it comes from in terms of the nested form. I'm going to do it step by step, and it might not make a massive amount of sense. It might be worth kind of going through it once and then focusing on the synthetic division and perhaps coming back to look at the nested form just so you can see where it comes from. If I just go straight into synthetic division, you're going to think, where the hell have all these numbers come from? What am I even doing here? But this will kind of show you why it works and show you why it's a simplified version, okay? So polynomials can be written using brackets if we kind of split things up into sections, because the problem is at the moment there was not a common factor here, but we're going to take a common factor out of the first 3 terms, and then we can kind of keep doing something similar. So obviously the first 3 terms divide by x here, in which case we can write it like so. Okay, and then if you look within the brackets, the first 2 terms divide by x, so we can write it like so. And then you can kind of rearrange this, okay? And it's basically just sticking the x's at the end. So it's ax plus b times by x, and then you'd add on c. And then you times all of that by x, and then you'd add on d. Right, this is the kind of the form, this is the process that we use that is basically the synthetic division. Okay, in this stage it's called nested form, okay? But we're going to use this to help us create synthetic division, okay? So this will help us to value f of x at a specific point and thus be able to factorize polynomials, okay? So here's an example. So f of x equals x cubed plus 7x squared plus 14x plus 8. We're going to evaluate f of 3. So all that means is we're just going to chuck the 3 into the actual equation, okay? But I'm going to do this in terms of nested form just to make it easier, because the problem is what I'm going to have here is I'm going to have 3 to the power of 3, 3 to the power of 3, 3 to the power of 2, sorry, times by 7. There's a lot going on here. But if I actually take out kind of the x's in the stages of common factors, it can be slightly easier to deal with, right? You're never going to have to deal with this again, okay? So don't worry too much about this, but this is just going to show you where the synthetic division, the bit that we're going to use quite a lot of, where it actually comes from, okay? So we can rewrite it like this, in which case it makes the actual substituting in of 3, because it might not necessarily be 3, it might be something like 27, which is going to be a lot more complicated for you to do. But if it was written in this form, it would be a bit easier. But what's basically happening is we're taking that factor, we're adding on, and what you can see here is basically the term of the coefficient of the second term here, and then we're going to take that and we're going to times it by this factor again, and then we're going to add on the coefficient of the next term. We're going to times that by 3, and then we're going to add on the coefficient of the last term. Okay, so there's a wee pattern emerging there, and that's what we're going to use for synthetic division. Okay, so take the point, add 7, then multiply by 3, add 14, then multiply by 3. We've actually multiplied by 1 as well here, okay, but it's just not written because it's 1. Okay, but we've taken that into account as well. And then we've got our answer, 140. Right, what this basically tells us at this stage is that it's not a factor, okay, which is useful for knowing for later on. So if that was equal to 0, then it tells us that 3 was a factor, in which case x minus 3 was a factor. You're going to see all this in a lot more detail. Okay, but this is just showing you where, as I say, the next bit's going to come from. Okay, whoa. So I'm going to take this and we're going to write it a slightly easier method using a table. What we're going to do in this table, as I say, this is going to come second nature to you. Okay, we're going to start with the degree of the polynomial down to the constant term. What you got to be aware of is that we need every single constant, every single coefficient here, okay? So it's not really a table, it's literally just two lines at a right angle to each other. But at the top of it, we're going to write the coefficients of each of our terms. So 1, 7, 14, 8. They're all positive here. If any of them were negative, then it would be -7. So for example, if x cubed minus 7x squared, then this would become negative, okay? And they go along the top. If, for example, you didn't have an x, so say it was just x cubed plus 7x squared plus 8, and that was just missed out, you'd have to put a 0 in here. Very important things to recognize, okay? We'll do some examples on that in a second. Okay, so it's basically just the coefficients of our different terms. Right, we're going to write over here. It doesn't really matter where it is, and you'll see lots of people, if any of you got tutors, they might put them at the bottom. It really doesn't matter, it's just on the left of the line. But that's the number that we're basically that we're substituting in, okay? And what we're going to do is follow this wee pattern, okay? So we start with a 1. We're going to take the 1, and what we're going to do is we're going to multiply it by 3, okay? In the same way that we did here, okay? This is where this 3 came from. We did 1 times by 3, and what you're going to do is you're going to rewrite that number, okay? Whatever answer you get for 1 times 3 by 3, you're going to stick it here, okay? And then what you're going to do is you're going to add on this number, so it becomes 3 plus 7, which is 10, okay? And then you're going to multiply it by 3 again, which gives us 30. You're going to add on the 14, which gives us 44. You're going to times that by 3, which gives us 132, and then you're going to add on the 8. Right, so what that does, that might seem a little bit kind of strange at this point, but what that does is it gives us a method of which to find a factor. Because what we're looking for, what we want this number here to be, we want this number to be 0. If we're going to factorize this, if we're going to find a factor, then this number being 0 would tell us that it is a factor, okay? So we're going to basically use this method as an easier way of finding factors, okay? Right, so when x is 3, f of 3 equals 140. As I said, there's kind of a lot of language parts to these kind of questions. So this is showing us a simpler method of finding the value of the polynomial at a given point. In other words, it's going to find the value of the polynomial when there's a root, okay? So we're going to try and use it to find factors. Okay, so if x minus a is to be a factor of f of x, then f of a will equal 0. Okay, so if we want a specific factor of a polynomial, okay, and say we want it to be x minus 3, or we think it could be x minus 3, or we're told that it is x minus 3, okay, then f of 3, in other words, when we put 3 into the function, then the number that we got at the end there would equal 0. And it's a way of proving that something is a factor. So here's an example for you. This is the first example, and this is what you're going to be doing a lot of from now on. So careful with the wording of this question. So given that x minus 2 is a factor, so it's telling you in the question that it is a factor, okay, of f of x equal to x cubed minus 2x squared minus x plus 2. What we want to do is factorize f of x fully. So this bit we haven't looked at yet. We're going to kind of contend with this in a second, okay? But we want to focus first of all on the fact that we know that x minus 2 is a factor, and we're going to use it to help us, okay, factorize it fully. All right, so we know that if x minus a is a factor, f of x, then f of a will equal 0. So therefore, if x minus 2 is a factor, then f of 2 should equal 0. Okay, in which case, when we put everything, all this information into the table that I just showed you, then we want the answer at the end, the number at the end, to equal 0. So we start by writing the numbers at the top, and these are just our coefficients. Remember what I said about the negatives? So we've got 1, minus 2, minus 1, and 2. Okay, so just the coefficients of our different terms. X cubed, x squared, x, and then the constant at the end. Okay. Right, we're told that x minus 2 is a factor, in which case we're going to be using 2 in our synthetic division, and then we just follow exactly like I did before. So we start by writing the 1 there, so whatever number that is there, we start it down here, okay, and we take that number and we times it by the number that we're trying to use as a factor, okay? So it'll be 1 times by 2, which gives us 2, and then we add on this number, so add on the minus 2, which gives us 0, take the 0 and times it by 2 again, that gives us 0, add on the minus 1, gives us minus 1, times by 2 again, gives us minus 2, and lo and behold, when we add the 2 on at the end, we get 0, okay? So what this tells us is that since f of 2 equals 0, so what we've done, that's this process here, we've found f of 2, and we've worked out that it equals 0, it tells us that x minus 2 is a factor, and therefore x equal to 2 is a root, okay? Right. The next stage is to factorize it fully. So that was the second part of the question, is to actually take it and factorize it fully. And what we've actually done here is we found these numbers, and these numbers are very, very important, okay? So the values at the bottom to the left of the remainder box are useful too. These give the coefficients of the remaining polynomial factor, or what is sometimes known as the quotient. In other words, the result of the division, okay? So basically what we've done is we've divided by x minus 2. So we've almost kind of taken out x minus 2 as a factor, and what we're left with is these numbers, and these are the coefficients of our remainder, okay? In other words, it's a polynomial itself, and the degree of that polynomial is one lower than the one with which we started. So we can rewrite the original equation, x cubed minus 2x squared minus x plus 2, as this. So we divided by x minus 2, okay, and we were left with this, basically, and we can create a polynomial out of this, and it's x squared, basically plus 0x, and then minus 1, okay? So we divided by x minus 2, this is what we're left with, and that, basically multiplied together, would equal what we started with, okay? And now we've got this, we've got a much easier thing to work with, okay? X squared basically minus 1, which we can factorize, okay, using traditional methods, okay? And we can find the fully factorized version of this. So this term is what we call the quotient, and it's made up of the coefficients from the left of the remainder box, okay? So the 0 does mean something. We can't just ignore it entirely. It just tells us that there's 0 x's, okay? So in order to factorize this fully, we merely factorize the quotient as a trinomial, okay? So if we started with a cubic, then obviously this term would be a quadratic, okay? Because as I said, it's 1 degree lower than what we started with. However, what's going to happen if this was a quartic, so if say we start with x to the power 4, we're going to end up with probably 4 terms here. One of them might be 0, but we're going to end up with 4 terms, and it would be x cubed. It would be a cubic, which then would mean we'd probably have to do this process again. But the beauty of that is that it means there's lots of marks for you in an exam, okay? So you're going to take this x squared plus 0x minus 1, write it as it is, which is x squared minus 1, and then you can factorize that further. That's just a difference of 2 squares, so it just becomes x plus 1, x minus 1, and that's the original term factorized fully. Okay, and there's lots of different kind of uses for this, and there's lots of different kind of questions surrounding this. It could be fully factorize it, it could be solve it, it could be find the roots, it could be find the points where it crosses the x-axis. You know, all these different things virtually basically mean the same thing, but we still use the same process to get to this point and just work out what the question asks us. So when you get to this point, go back and read the question and see what it's asking for. It's just asking us to, I think it asked us to fully factorize it, but nonetheless, the factors would be 2, minus 1, and 1, okay? And that's basically it. Okay, that's kind of your first polynomial at least, and that's what we want to try and do. So I'll show you another example, just so that we get this down to a T. Okay, so we're going to show first of all that x minus 2 is a factor of this, and then we're going to factorize it fully. Okay, so again, these are the more common type of question. You're told one factor, and then you have to find the others. If you weren't given a factor, and I think I'll look at that in the next example, if you weren't given a factor, you'd have to kind of do a bit of trial and error first of all. But this is a factor, so we can actually use that to help us. Because if x minus 2 is a factor, then f of 2 will equal 0, okay? In which case we can go straight to our table, and we've just got to be careful here. So this is what I was pointing out. So this is a cubic, but notice there's no x squared function, right? What that means is that when we write out the coefficients at the top here, we have to have a 0. So don't just write 1 minus 7, 6. It's all the different coefficients. So it's x cubed, x squared, x, and then constant. And you have to have the coefficients of each one. So in the question, there might not actually be a coefficient there, but you know that there should be an x squared there, or there's just 0 x squareds there, in which case there has to be a 0 in your table, okay? All right, the process from there is just the same. So the 1 comes down, and we take the 1 and we times it by 2, which gives us 2. We add on 0, which gives us 2. We times by 2, which gives us 4. We add on minus 7, which gives us minus 3. We times by 2 again, which gives us minus 6. And then we add on 6, and it gives us 0, right? We knew it would be 0 there. We know it's a factor. It's told us it's a factor. So if that's not 0, and we've gone through all of this, then you've done something wrong. So again, it might be this, that you've missed out the 0. It might be that you can't add, you can't multiply. But either way, this has to be a 0, okay, because we know it's a factor. But nonetheless, we'd say this, since f of 2 equals 0, x minus 2 is a factor. But that's one and only factor that we've got so far, but we can use these 3 numbers here to help us find the rest. So what we call this is the quotient. That should just come out in one go, but nonetheless. And that's basically the remainder when we divide by x minus 2. So it's almost like if we take x minus 2 out as a common factor, we'd be left with, in the other bracket, x squared plus 2x minus 3. Okay, just like it's written here. And then all you do is you take that quadratic and you factorize it in the normal way. Okay, x and x, factors of 3 that take away to give you 2, 3 and 1, different symbols, biggest one's plus, plus 3 minus 1, and that is it fully factorized. Okay, as I say, the question might have said, what are the roots? Where does it cross the x-axis? It might say solve it fully, in which case you'd need one more step, or in which case x would just equal 2 minus 3 and 1. So read the question carefully and see what it's actually requiring of you. Okay. Right, so I think this is probably the last example. This is quite a long video, this one, okay, but this is dealing with a slightly bigger one. This is a quartic now, okay, so fully factorize 2x to the power 4 plus x cubed minus 6x squared plus x plus 2, okay? Right, the problem with this one is it doesn't tell us a factor in the first instance, okay, so we've got to find our own factor, okay? There's not an easy way of doing this necessarily. You can kind of use some of the numbers to help you. So the fact that there's a 2 at the end here might help you a little bit, okay? But generally what you want to do is you want to guess and just see if it works, right? You can use a synthetic division table every single time if you want to, but we know if it's a factor, if we basically replace the x's with the number and we get 0 at the end, okay, then we know it's a factor, okay? So for example, if I replace all the x's with 1, then I get 0. Okay, so 1 to the power 4 is just 1 times by 2 is 2, plus 1 is 3, minus 6 is minus 3, plus 1 and plus 2 gives me 0. Okay, so that is telling me that 1 is a factor, well, basically x minus 1 is a factor. Okay, so since f of 1 equals 0, it tells me that x minus 1 is a factor of f of x, and I can use this to basically start my synthetic division. Okay, so that just finds a factor. It's obviously a good place to start, but remember you can check your negatives as well. So you can try with 1, you can try minus 1, and then you just need to keep going until you find one, okay? Right, so I'm going to take this fact to allow me to start a synthetic division table, okay? So remember the coefficients across the top, we've got an extra 1 this time, so we've got 2, 1, minus 6, 1, and 2, and I know that x minus 1 is a factor, so I can work the 1 through, and obviously I know it should be a 0 at the end, okay? If my working so far is correct, which it is obviously, then this should be a 0 at the end, but then it's going to give me the terms that we're going to build up my quotient, which is going to allow me to factorize it fully, okay? So bring the 2 down, times it by 1, gives me 2, add 1, gives me 3, times it by 1, gives me 3, add minus 6, gives me minus 3, times by 1, gives me minus 3, add 1, minus 2, times by 1, minus 2, add 2, 0. Lovely. Right, so since f of 1 equals 0, x minus 1 is a factor. We already knew that, but this is basically, I have to do this process to get these 4 numbers here. Okay, so the quotient is 2x cubed plus 3x squared minus 3x minus 2. So this needs factorized 2, but the degree is 3, so we're going to have to use synthetic division again. Okay, but again, we have no factor to start with, so we guess and try for the second time. Okay, so 1 could be a factor of this. You could have kind of 2 factors, which it is. So x minus 1 is a factor again. There's nothing wrong with that. Okay, so all it means is I've got to go for a second synthetic division, but I'm using the coefficients from this next term, from the quotient of the first one. I've got 1 is my factor again. Okay, so I'm just going through that process again. 2 times by 1 is 2, add on 3 is 5, times by 1 is 5, add on minus 3 is 2, times by 1 is 2, add on minus 2 is 0. Since f of 1 equals 0, x minus 1 is again a factor. Okay, it doesn't mean that it's just the one factor. It was a factor of the first one, and then we're left with this. It's also a factor of this, so it's a double factor. Okay, it's a repeated root, which is going to be useful later. Right, so the quotient here is 2x squared plus 5x plus 2, and we can factorize this as a trinomial. Be careful with the notation, though. Okay, so the idea is that we've taken out 2 factors. X minus 1 was a factor, and it was another factor. Okay, so when I rewrite this, I've basically taken out the 2x minus 1s, and I'm left with 2x squared plus 5x plus 2. Okay, and then all I want to do is factorize that fully. However you choose to do it, you'd get 2x plus 1 and x plus 2, in which case we've got 4 factors. Okay, fair enough, one of them is repeated, and you could write that as x minus 1 squared. But we can use this obviously to start drawing our graph, find where it crosses the x-axis, whatever is required. But all we were required to do here was just factorize it fully. Okay. Right, I think I'm going to leave that there.